Very good morning, and you're welcome to today's Signpost webinar, coming to you on a somewhat overcast day after our summer solstice. Today we're going to be talking about climate change, and we do know that human activity has resulted in widespread and rapid changes in climate, which are already impacting us all today. So today we're going to be discussing the impact of climate change that's having on our weather patterns. And we're delighted to be joined by Professor Conor Murphy, who is a Professor of Climate Change in the Department of Geography at Maynooth University. And Conor is going to be talking to us today about that clear signal that climate change is sending to us around weather and weather extremes. Conor, you're very welcome to the webinar.
Thanks very much, Mark. It's a great pleasure to be here.
And we're also joined by John Greaney, who's going to help us with questions later on. And do take that opportunity to use the Q&A tab at the bottom of your screens to send us your questions. We'll be allowing lots of time at the end of Conor's presentation to take questions. Before we get into the presentation, Conor, maybe you could just tell us a little bit about the work that you're doing in the Geography Department there in Maynooth University.
I can, of course. I'm part of ICRIS. It's a mouthful. It's the Irish Climate Analysis and Research Units. And we've been dedicated over the last 15 years or more about understanding how climate is changing in Ireland and internationally, what the key impacts are across sectors, and really understanding our policy response, particularly around how we can adapt or change to meet the challenges of the changes we're seeing. So we do all kinds of things, from research to advising policy to producing policy reports and international publications and all that kind of thing. We're really trying to guide Ireland in reaching its national climate objective, which is a climate neutral and climate resilient Ireland by 2050. We're really interested, personally, I'm really interested in that idea of being climate resilient.
Mm-hmm. And how far do you think we are on that journey to adapting and building that resilience? It seems that a lot of the focus tends to be on the climate or emissions reduction rather than that adaptation piece.
Very much so. It's often a frustration I hold when we talk about climate action. People immediately think about greenhouse gases and emissions reduction, but actually that's just part of climate action. The other part of it is adjusting our practices, our systems, to make sure that we avoid the worst impacts of change and make benefit of any positive changes that do occur. So we really need to change the dial on the climate action conversation, is talking more about adaptation. My take-home message today in the talk is that climate change is happening now. We can see the impacts. We see the impacts for farmers. We see the impacts on coastal communities, on extreme events and floods. So we need to give adaptation more precedence or more importance in our policy discussions.
Great, right. Okay, Conor, if you could share your slides, your first slide with us, and look forward to your presentation on debunking some of those myths around climate change. So we can see, yeah, that's coming through there now. And just a reminder again to everybody, the Q&A tab is at the bottom of the screen, and today's session is recorded and will be available on the Teagasc YouTube channel along with Conor's presentation. So I suppose an early health warning, there are lots of graphs and a few tables in Conor's presentation, but they're there on purpose for you to be able to pick up on some of the detail later on. So Conor, you're going to talk us through those nice and gently through the presentation. So we'll hand over to you, Conor, and look forward to our discussion afterwards.
Great, thanks a million. And again, thank you for the invitation to present. It really is a privilege to be able to present to the Teagasc Signpost Series. So I want to talk about the clear evidence we now have for climate change signals in Irish weather and extremes. As Mark mentioned, there are lots of graphs here. Please don't be put off by that. I do that to show the data, to show the evidence, and I'll talk around those. And of course, if you have any questions at the end or points for explanation, clarity, or further digging deeper into anything, I'm very happy to do that. So I want to start by talking about a recent important national publication that was called Ireland's Climate Change Assessment Report. And this was a really comprehensive report characterising the state of play where we're at with climate change in Ireland, looking at the impacts, the science around climate change in volume 1. In volume 2, looking at mitigation of greenhouse gases across different sectors in Ireland. Volume 3, which I was a lead author on, was a volume that looked at how we can be prepared for Ireland's future climate. And that really looked at impacts across different sectors of the Irish economy, including agriculture. There's a whole chapter on agriculture in there. So if you're interested in that, I'd urge you to have a look. And thinking about where we're at with adaptation to climate change. So we have 2 policy responses I've mentioned. Mitigation is about greenhouse gas emissions reductions, and fundamentally that's about reducing the impact of future climate. And adaptation is about putting in place the changes to our practices, creating more resilient infrastructure, changing how we do things to offset or to avoid the impacts of climate change that are already present or will be baked into the future. And what I'm going to show you today is that climate change is already happening, and the future that we're facing is likely to see increased impacts of climate change. Even if we stopped all greenhouse gas emissions tomorrow, brought them to zero, we will still be facing climate change impacts over the coming decades because there is an inertia in the climate system. It takes a number of decades for emissions to work their way through the system. So that really brought us to these main conclusions about where we're at on adaptation to climate change in Ireland at the moment. We very strongly conclude in this report in volume 3 that climate change is happening now and we need to adapt. We've seen some extreme events recently that are very clearly show a climate change signal. Our long-term records, and in Ireland, we're really blessed in terms of having some of the longest, best quality weather records anywhere in the world, and I'll talk about those in a few moments. And they show us clearly that the climate change signal is emerging in Irish weather, in temperature, in rainfall, and in extreme events like in floods and in droughts. So climate change is happening now, and we need to adapt. But we're not starting from an ideal position. We're seeing degradation in water quality. We've seen a lack of resilience in our infrastructure, a lack of investment in infrastructure. So we do have a bit of catching up to do to put us where we need to be in terms of adaptation to climate change. And we need to shift that policy focus in terms of not just talking about mitigation, that remains very important, but because climate change is happening now, because we are vulnerable, and because we are committed to future changes, we need to bring adaptation higher up that policy ladder. And both adaptation and mitigation, these policy responses are inherently linked. The better we are at mitigation, the less adaptation we will have to do. But at the same time, because of greenhouse gas emissions, we're already committed to climate change and we need to continue investing or increasing that investment in adaptation. So what I want to do is to show you that evidence for, I guess, that first statement, climate change is happening now and we need to adapt, and to try and make it relevant for the agricultural sector. So we've recently been working on different EPA-funded projects, particularly the Hydro-DARE project. It's around detection and attribution of climate change in weather and extreme events, about looking to see if we can see the emergence of a climate change signal in Irish weather records. And as I said, we have a really long history, an impressive history of weather observation in Ireland. We're able to leverage those long-term records in order to increase our confidence in what's happening with local scale weather and climate. These are three different maps that show really long-term records on the left-hand side, on my screen at least, are long-term temperature records from across the island that get back into the 1800s. These have all been quality assured by work done by colleagues at Maynooth University and Met Éireann and NUI Galway. And they provide us a really nice insight into what's been happening with Irish temperature records over more than a century at this stage. In the middle in B is a network of long-term monthly rainfall records, and they get back all the way to 1850. And they really give us an impressive understanding of rainfall changes across the country. It's a fairly good spatial distribution across the country of where these stations are located. And they've all been quality assured and what we call homogenized, making sure that changes that we see are not due to changes in instrumentation or different gauge design or observational error, that they are a real and true picture as much as we can be confident of what's actually happening with rainfall across the island. And on the right-hand side is the output of recent work with Met Éireann, where we have been developing a long-term daily rainfall record. So monthly is okay for looking at things like drought, but if you want to look at extreme rainfall events, which have been so impactful for agriculture, particularly last harvest season, we need to have these quality assured daily records. And these stations get all the way back to the very start of the 1900s. And again, these are all among the longest, best quality weather records for temperature and rainfall anywhere in the world. So we're really lucky to have them and to be able to leverage them for understanding what's happening in Irish climate. So a science slide, but bear with me, you don't need to understand the detail, I'll explain it. What we did with these weather records is that we extracted different indicators of weather extremes. So looking at European work has identified these menu, if you like, of extreme weather variables for temperature and for rainfall. It might be rainfall intensity, for example, or the number of very wet days, or maximum 5-day rainfall totals for rainfall. Or it might be cold spell length or dry spell length, or growing season length, or the hottest day, coldest day indicators for temperature. So we extracted a large number of these, and please don't even try to read the slides. It's just to emphasize the fact that we extracted a large number of temperature and rainfall extremes at a daily level, but also at an annual and seasonal level. And what we did in this research is that we tried to relate what's happening locally at each of these stations to what's happening in terms of global mean surface temperature. If there's one metric or data set out there that really emphasizes the impact that humans are having on climate globally, it's this global mean surface temperature record. Scientists have shown that all of the change that we've seen in that global surface temperature record is due to human greenhouse gas emissions. So we tried to relate what's happening locally with what's happening with global mean surface temperature using statistics, basic regression if anybody is interested. And that allows us to scale what's happening locally with what's happening with global mean temperature. And where we see a relationship between those, we can be confident that what we're seeing is a change locally that's driven by climate change, or anthropogenic climate change in particular. So it allows us, in its science terms, to separate out the signal, which is the climate change signal, from the noise of background variability. And what's really important is this symbol here, this alpha value. It allows us to develop a scaling that relates what's happening locally to what's happening globally. So for every, for example, 1 degree change in global temperature, we can relate that to what's happening locally. And that will become important in a minute. So remember that alpha value. And in relating the signal to noise, what we do is we describe the kinds of changes we're seeing relative to early industrial climate. So if you were living in a time before humans were changing the composition of the atmosphere, we relate the signal to noise ratio to, if it's less than 1, we characterize as normal. If it's greater than 1 but less than 2, that's unusual relative to early industrial climate. And if it's greater than 2 and up to 3, that would be an unfamiliar climate to somebody living in the early industrial period. So again, that's accessible. We talk about normal, unusual, or unfamiliar climate in terms of the emergence of a climate change signal. So I just want to talk about this alpha variable for a moment. So it allows us to scale what's happening locally to global surface temperature. And the graph that you see here is a projection or observations of global temperature on the left, this black line, and then projections of what's likely to happen globally in terms of warming out to the end of the century. All of these different numbers on the right-hand side are different emission scenarios. Staying within the Paris Agreement of limiting global temperature to no more than 2 degrees, this is the line that we face. If we are not so successful and we continue on these higher emissions trajectories, this is the kind of change in global surface temperature we expect to see. The very worst case scenario is this SSP 5, where we're probably, I guess, if you were to ask me, somewhere in the middle here at this moment in time. But what's interesting is that because of this work, we're able to relate what's happening locally to units of increment, 1 degree changes in global surface temperature. So even using these long-term observations, we're able to think about the future. So if the change we're seeing locally can be scaled to global temperature, what if we see 3 degree rise in global temperature or a 2 degree rise in global temperature into the future? Okay, so what did we find? So I'm going to start with annual and seasonal temperatures. Can we see the evidence of emergence of a climate change signal in these records? And the answer is unequivocally yes. So these are long-term temperature records for annual spring, summer, and autumn seasons. And where you see these red triangles, they're pointing up, so temperatures are rising, and we're seeing the emergence of an unfamiliar climate. That signal is greater than 2 in all of these red areas, in the East Coast, in Armagh, Malin Head, and in the Midlands in Birr. We're seeing the emergence of an unfamiliar climate in our annual mean temperature relative to early industrial. And even in the west of Ireland, we're seeing the emergence of what we call an unusual climate relative to early industrial. For the other seasons, things tend to be within the unusual category, but in all seasons except winter, we see a very close relationship between what's happening locally and what's happening in the global surface temperature record. And that's evidenced here in this alpha column for all of the different rainfall all of the different temperature stations that we considered. They all show a significant relationship with global temperature, and they show us that for parts of Ireland, we're warming actually at a rate faster than the global temperature record. So for Phoenix Park, Glasnevin, Dublin, Armagh, and Birr, they're rising by more than 1 degree for every 1 degree rise in global temperature. So often you might hear the fact that, oh, Ireland temperature rise won't be as great because of the fact we're in the Atlantic Ocean, that our climate is modified by that, or is temperature rise are dampened by that. Some parts of Ireland, particularly in the eastern half of the country, are warming at a rate that's greater than the global average. When we look across all of the temperature indices, we see clear evidence for the emergence of climate change and temperature extremes across all seasons. In particular, we see the emergence of unfamiliar climate in variables like cool days and cool nights. We're seeing big decreases in them, and they have become unfamiliar relative to early industrial climate. Warm days and warm nights are increasing, and they show very large signal to noise ratios. We really clearly see the climate change signal coming out in these variables annually and seasonally. If we were to look across all this, the seasons that's seeing the greatest amount of change is the spring season, where the greatest number of different indices are showing the emergence of a climate change signal. You can see this on the graphs. This is the dashed line 1 here, shows the threshold for unusual climate, and between 1 and 2 is unfamiliar. And you can see the number of stations in these different plots are all included here. The average is the black line, but they show the spread of the result for all the stations across Ireland. So we really are pushing towards the emergence of an unusual to unfamiliar climate relative to early industrial period, driven by climate change. What was surprising, I must say, from this analysis for temperature records is that the hottest days of the year, which we often associate with climate change in the public imagination, we don't find the evidence that a climate change signal is evident in those hottest days of the year, which was quite a surprise to us. And that might just be because of variability, and that the signal is yet to emerge from the noise of background variability. Moving on to rainfall indices, again, we looked at annual and seasonal totals and also different rainfall extremes. To give you a sense of what these are, RX5 is the cumulative 5-day rainfall total. Rainfall intensity is this SDII, so that's the amount of rainfall falling in individual events. And then how heavy rainfall totals are giving rise to the overall annual total in the year. What's immediately obvious and of no surprise is that there is less of a signal emerging in rainfall because it is much more spatially variable. It's noisier than temperature. But even despite that fact, we are seeing the emergence of unusual climate across different stations in Ireland. Notable will be the emergence of a climate change signal in the west coast of Ireland in terms of annual totals. But particularly important is the emergence of a climate change signal in rainfall intensities. So again, you may have noticed that rainfall seems to be happening. When it happens, it's heavier. That's often relayed to me from public awareness, and our data set shows that that is the case when it comes to looking at rainfall extremes. And that also is consistent with what we expect from a physical point of view. So as the atmosphere warms up, it holds more moisture. That's known as the Clausius-Clapeyron relationship. For every 1 degree rise in temperature, we expect a 7% increase in the water holding capacity of the atmosphere. So when it rains heavier ultimately. And that's exactly what we're seeing in our results. So again, looking at the alpha variable here, for every 1 degree rise in temperature, we're seeing all of these stations an increase in rainfall intensity that's consistent with physics, with our physical understanding, and is likely to continue to do so in future. So for every 1 degree rise, for example, in Folks Mills in Wexford here, we're seeing an 8% increase in rainfall intensity. For every 1 degree rise in global temperature, for example, in Malin Head, we're seeing a 10% increase in rainfall intensity. So that's why this alpha value is really useful, because it relates what's happening locally to what's happening globally. So if we fast forward to a world in the future where we're 3 degrees warmer, 3 for 3 degrees and so on, we get a sense of what the impacts of climate change can be based on just our observations. And it adds another string to the bow of using climate model projections, which people often question. This is from the observations and scaling what's happening in the observations. And they're actually very consistent with what we expect from climate model projections. So we're seeing an increase in rainfall intensity that's related to climate change that's very much in line with our expectations of our physical understanding and from climate model projections. And this brings us back to agriculture. So we've seen in recent years some extreme weather events that have impacted dramatically on agriculture. One of those that sticks in my memory is from the harvest of last year, in last autumn, particularly in October. I found myself down in South Wexford doing an interview for Ear to the Ground, where I was standing in fields where crops were left. The ground was too wet to harvest. Heavy rainfall events had damaged the crop itself, but the very wet conditions leading up to that had given rise to major agricultural losses. Over 5,000 acres of crops unharvested in parts of the country, particularly in the southeast. And the IFA recently produced this assessment of the impact of that extreme weather on individual farmers. Hugely problematic year because of weather conditions throughout the summer and into autumn. That were also, I guess, aggravated by other things like the high cost of fertilizer, high cost of fuel in 2023, the challenges for grain prices. So this highlights to us the real importance of adapting to climate change. We see the climate change signal emerge in rainfall, impacting on agricultural practices and on crops. But at the same time, we're seeing things happening in the non-climate world in terms of the cost of fertilizer, the cost of living. And adaptation is really about thinking how we can adjust our practices, our supports for farmers, in this case, in order to meet the challenges that are presented by climate change. For winter rainfall, while we don't see a clear emergence of climate change yet in winter rainfall totals across all of the country, what we do see are very large alpha values. So as the climate is warming, we're seeing a large potential for an increase in rainfall totals in winter. And some of these are quite large. I highlight in red where we see a significant relationship between winter totals and global temperature records for Irish weather stations at Valencia, Shannon Airport, Dublin, all of those in red. And what you can see is that for every 1 degree rise in temperature, we're seeing large increases in winter rainfall totals. And that indicates to us that the future will hold a pretty significant increase in flood risk, particularly in the western part of the country as we move forward. Okay, to wrap this part of the presentation up, we also took a look at the island of Ireland scale. So averaging all of these records to come up with an island of Ireland average. And what we see again is that clear evidence for the emergence of climate change. We see the emergence of unfamiliar climate in a number of different climate variables. Particularly the annual number of cool days is decreasing and cool nights are decreasing pretty dramatically, and have decreased to an unfamiliar level relative to early industrial climate. The largest increasing trends we've seen from a climate change point of view are for warm nights and annual mean temperature. And again, these are well above, show a very clear signal relative to the noise of variability. We saw the largest signal to noise ratio for annual mean temperature, with warming of the island of Ireland as a whole estimated to be at about 0.88 degrees Celsius per degree warming in global temperature. But again, as I mentioned, some parts of the island, particularly in the east of Ireland, are warming at a rate that's faster than global mean temperature. So what can we summarize from this? We can now identify the emergence of human-driven climate change signal in long-term quality assured observations of precipitation and temperature across Ireland. Of all of the indicators that we analysed at annual and seasonal basis, about 903 tests in total, 37% show the emergence of conditions considered at least unusual relative to early industrial or natural climate for this part of the world. The largest changes are in annual mean temperature that are unfamiliar to early industrial, and 6 of 11 stations show that signal at the island scale. For rainfall, annual rainfall totals are unusual relative to early industrial climate, and for Western stations, we see large increases in winter totals for every degree warming globally. Changes in rainfall intensity that we see emerge at about 30% of stations are really consistent with our physical understanding of what happens in a warmer atmosphere. And these changes are already impacting on agriculture. And we have a useful tool here now for scaling local data or local changes to global mean temperature that allows us to think about what might happen locally for different landing points of climate change in the future, depending on how successful we are at reducing greenhouse gas emissions. Moving on to additional work that we've done, you may have seen in the news that we've been able to do the first event attribution for climate change using the Midleton floods from last October as well. So last October saw Storm Babbitt arrive that resulted in widespread flooding in Midleton and Cork. And we were able to show, using our long-term observations, using our climate models, that the risk of this kind of flooding has increased about 120% because of greenhouse gas emissions. So we looked at things like land use change in the catchment and concluded that that wasn't sufficient to explain the magnitude of the event. We looked at the rainfall totals over the preceding 3 months, and we looked at the rainfall intensity in the day before and the day of the storm. And what we found in particular is that the climate change signal that's very clear in those heavy rainfall events, those intense rainfall events, is where the climate change signal is evident in the Midleton flood. And of course, as bad as the Midleton flood was, it occurred at a low spring tide, so it could have been a lot worse. But this was a costly event that has been driven and has been made more likely as a result of climate change signaling in records. When we look across the risk of flooding across Ireland, we also see the emergence of climate-driven changes in floods across, particularly in the Shannon Basin. The map on the right-hand side, those blue triangles show where we see a significant increase in floods. And in particular, it's located around the Shannon Basin. And when we look at the data sets from that and we try and reconstruct them using just climate variables alone, you can see that we do a very good job just looking at climate and trying to predict these annual maximum floods going back over time at each of these stations. The graphs on the left-hand side are a sample of those stations from the Shannon Basin. And climate alone can very clearly replicate the increasing trends in floods that have been seen in the Shannon Basin. So again, a smoking gun here for climate-driven change being the factor behind the increase in floods we're seeing in the Shannon Basin. Other parts of climate change that are important for agriculture and may not be very clear in the public imagination include sea level rise and coastal erosion. There's evidence, for as an island nation, for example, we are exposed to land loss from coastal erosion. And that's not likely to change anytime soon. So when we think about reducing greenhouse gas emissions, that's about stabilizing what's happening in the atmosphere. But the oceans respond at a much slower rate. So it's going to take an awful lot longer for the oceans and sea level rise to stabilize into the future. So when we talk about the impacts of sea level rise and coastal erosion, we really need to be thinking over the next couple of 100 years. So climate change will continue through sea level rise over a course of hundreds of years, even if we stabilize greenhouse gas emissions. So this is already baked in, if you like. But the higher the emissions of greenhouse gases, the greater amount of sea level rise that we expect to be confronted with. We're already seeing the impacts of changes in coastal erosion. The image on the right-hand side is from my local area. I'm in North Wexford. This is Kiltennel Beach in Cortown, and you can see the extent of rock armour, and nonetheless, you can see the continued rates of erosion. This is one picture. We're also seeing a large loss of land affecting farmers in parts of the southeast of Ireland. The next slide, this slide here shows work that we did with our students in Maynooth University, going down to Kilpatrick Beach in North Wexford, and mapping the amount of coastal erosion that's been happening there over the last 150 years. So different periods of historical mapping in Ireland, you can see clearly the retreat of the coastal area, the loss of important land affecting local, or exposing local houses, to example, or infrastructure to erosion risks. And we've seen approximately, on average, almost 230 meters of land lost since 1900. That's quite shocking to me, and this is happening across large parts of our coastal areas, putting at risk agricultural land. There are many reports of farmers in Wexford, for example, losing valuable agricultural land from coastal erosion. And what we're able to show is that rate of retreat is increasing. So it's been, for example, the average rate is 1.85 meters per year since about 1900, and that rate has been increasing since about 1980 or thereabouts. So sea level rise, coastal erosion is an impact for agriculture that we don't often think about, that I wanted to draw attention to. To finish out in terms of impacts for agriculture, I want to talk about drought events. So again, in 2018 in particular, we saw how sensitive or how vulnerable the agricultural sector was to drought, impacting in particular on grass growth following after the beast from the east and extremely cold conditions earlier in the year. And again, we're able to leverage these long-term records we have and place them in a European context. And believe it or not, the trend that we see in drought risk in Ireland, we're seeing a trend towards more severe drought, particularly in summer. And that's among the largest trends anywhere in Europe. So these maps on the right-hand side, keep an eye on those brown colors on the rightmost map relative to what's happening across Europe. The largest trends towards more severe droughts are happening around the southeast and south of Ireland in a European context. So we're seeing a strong trend from the 1800s up to present of a move towards more severe droughts. So what happens when we look at future droughts from climate model projections? Here, it's really important when thinking about future droughts of thinking of the changes in rainfall, but also how increased temperature results in greater evapotranspiration losses. And particularly important for agriculture is what happens across multiple seasons, for spring into summer. And these graphs on the maps on the left-hand side show the reference condition, which is representative of current climate, and what might happen in the future across the island of Ireland for a middle-of-the-road emission scenario in the middle. So if we're somewhat successful at reducing greenhouse gas emissions in the middle, and if we're not successful at reducing greenhouse gas emissions. What you can clearly see as we move from the present to the future is that we see an increase in the magnitude of drought events across the island, particularly in the east and the southeast, in this location in spring, and more significant droughts across the island in the summer period. So we're seeing an increased likelihood of drought in spring continuing into summer, and the higher our emission scenarios in the future, the greater that increase in drought risk is into the future. And we're also seeing an indication towards longer drought events. Because of that increase in spring drought conditions into summer, the duration of drought events is likely to increase into the future. 2018 was an impactful event for agriculture in Ireland for drought. But when we look at these long-term records, 2018 was not that remarkable in terms of its duration or its overall severity. And that's highlighted by the fact that we are highly sensitive to drought. We don't talk about drought enough. When it happens, we're not that well prepared. But in Ireland, we have these really long newspaper records that, again, are really impressive and allow us to get an insight into vulnerability and impacts of extreme events going back over time. And we've been doing that with our records, looking at the Irish newspaper archive and categorizing and saving down impacts of different droughts on different sectors. So for agriculture and livestock over the period 1900 to present, on public water supplies, on fisheries and aquaculture and freshwater ecosystems, and categorizing all of the different drought impacts from newspaper records. And again, you can see clearly that by far the most important two are agriculture and livestock and public water supply, but agriculture and livestock is the most frequently reported drought impacts in Ireland, unsurprisingly. But what that allows us to do is to look at how sensitive droughts in different parts of the country are. The blue is the east, the red is the west, the grey line in these is the Midlands, and these graphs on the right-hand side. And you can see very clearly that we don't have to get to extreme drought events to have a probability or a likelihood of impacts being reported according to our newspaper records. So this shows across each of these regions, the likelihood that we'll start to see, or the probability we'll start to see impacts from drought and agriculture being reported in newspaper records. In the summer periods, for example, we only need small deficits relative to average conditions for drought impacts to start to be reported in newspaper records, particularly in the east and southeast of the country. So this allows us to highlight the real sensitivity to drought events in Irish agriculture. And that is, we can look at how that changes over time. Of course, there's been a lot of changes in technology and cropping and practice over that time. But even if we take a short period, the last 20 years or so, we can still see that sensitivity to drought in summer periods in particular being high in Irish agriculture. So my last slide, we have this national objective of realising a climate resilient Ireland by 2050 at the latest. Agriculture is crucial to Ireland. It's part of who we are as people, and it's part of our national economy. But we are very exposed to climate change in Irish agriculture. We're already feeling the impacts, as I hope I've communicated to you in this talk. We need to shift our focus. We need to increase our focus in terms of planning and adaptation in the agricultural sector to protect us from the impacts that are emerging now and will continue to grow into the future. And that adaptation has to be joined up across all sectors. Agriculture is really important connections in terms of health and well-being and the impacts that extreme events can have on the farming community through the health, in terms of water, in terms of flooding and so on. So there's lots of cross-sectoral interactions, and we need to be thinking about those when it comes to adaptation in agriculture. And when it comes to climate change, we have as much information to act now as we will ever have, and we need to increase our focus on adaptation. The future that we see is in our hands, and we need to not forget that mitigation and adaptation are closely linked. The background here are what are known as climate stripes. This shows global temperature from 1850 into the future to the end of the century. Our choices will dictate the climate that we see. In a delayed action world where greenhouse gas emissions continue to increase, we will have greater impacts in which we need to adapt to. For a more moderate world where we reach that targets of 2 degrees or 1.5 warmer world in the Paris Agreement, we will still have to adapt, but that adaptation challenge will not be as severe. And I'll leave it at that, and I'm happy to answer any questions.
Brilliant, Conor. Thank you so much, and for taking us through that. And yeah, the graphs. There's no questioning the data for sure. I mean, it's pretty obvious there's changes happening, and I think every farmer in the country will remember the effects of the drought in 2018 and I suppose how it did expose how sensitive the systems are at the moment, and I suppose the need to build that resilience into our agricultural systems, and I suppose across all parts of society. And I know that EPA report has gone some way to identify some of those changes required. You talked about 120% increase in the occurrence of extreme rainfall events. Could you talk to us more about that figure?
Yeah, so the clearest signals of climate change we expect that we expect to be able to detect at the moment are changes in temperature, but also rainfall extremes. And we're seeing that very clearly. Sometimes above that 7%, you get, for example, local topography interacting with what's happening in the atmosphere, and you see amplified increases in rainfall extremes. So places like, Dublin is well understood for, you have the Wicklow Mountains there that can increase rainfall extremes for the city. But that's also the case in other parts of the world or other parts of the island, particularly for Storm Babbitt in Middleton, where it increased the risk of that flood event by 120%. You have warm moisture being carried up from the southern parts of the Atlantic Ocean off the coast of Spain and Portugal. And then when that makes landfall, it gets uplifted and you get deposition, lots of heavy rainfall. So that warmer atmosphere increases that amount of heavy rainfall, particularly around the south of the country is where we're seeing that signal emerge, the southeast and into the south, because of that movement of warm moisture up from the Atlantic, from the South Atlantic over Ireland, seeing that heavy rainfall event. And that's what we expect. That's there from physical basic physics of you heat up an atmosphere or an air mass, it holds more moisture. That's basic physics, and we're seeing that happen. We're seeing that in our observations. We're seeing that in our models. So that heavy rainfall, extreme events and rainfall, it's clearly climate change, and it's clearly here, and it's clearly going to get worse the more we warm our planet.
And so from your perspective, and I know it's included in a lot of those policy papers that you've been involved in, what sort of changes do you think are needed within farming in Ireland to respond to these future climate or weather patterns?
Yeah, so I'll have a go, but you guys are the experts on this.
Yeah, and I appreciate that, but I do appreciate
Yeah.
the sort of the non-agricultural view as well. Just from a distance, maybe you do have a unique perspective.
Yeah, and most of my perspective is towards trying to build resilience in water resources, in floods, and that kind of thing. But a lot of that is transferable too. So thinking about practices in terms of the kinds of crops that are grown and are they fit for purpose in a warming world? Yes, they might be fine for next season or the season after, but again, thinking about that longer term planning, what we need at a national scale, the role of Teagasc in that, in terms of the kinds of resources that might be available. So on farm water storage for the drought events, to better use of seasonal forecasting. We have kind of tools for weather. We use these short-term weather forecasts, but in other parts of the world, and we've shown in Ireland as well in research we've done, we can develop skillful seasonal forecasts to help this kind of weather-dependent agricultural activity. We can have a look at governance structures and support mechanisms that are put in place, making sure that there's access to insurance for losses. The heartbreaking issue I saw in Wexford last year was all of people's investment had been put into this, and we were literally looking at their annual income in the ground and the challenges that presents to people in terms of their own mental health, well-being, sharing innovations or practices and resources among farmers. Really important things. We saw in 2018 work that we've done in looking at the impacts on health and well-being for farmers, how important, I guess, Irish community is, sharing resources among neighbours, sharing insights of what they've done to cope, what worked, what didn't, all of that learning during extreme events. One of the things we need to be aware of when it comes to agriculture, and it was an insight from 2018, is that drought events in particular tend to have a big spatial footprint. By that I mean most of the country was impacted, but also our trading partners were impacted. So England, Northern France, where we were looking for fodder, were also impacted by drought events. So drought is a big spatial footprint. It's a regional scale event in many cases. And that can create additional complexities that are cross-border even. So even thinking about agriculture is our supply chains and how they may be impacted by climate change or extreme events. You see how those supply chains were impacted for fertilizer prices, for example, and international geopolitical things impacting agriculture through fertilizer prices, So we need to be thinking outside the box. It's not just thinking about climate, it's thinking about what are the things that we need to be resilient to, what are the basic inputs, and making sure they're available to increase our resilience to deal with the climate event. So avoiding exceptionalism, I think.
Yes. No, and I think that we need to look at that vulnerability along the supply chain, and farmers are at the front line of this, and that needs to be reflected along the supply chain. And I think also, look what's happening in other countries. You talked about the the countries similar to ourselves. But then there's there's the likes of Spain who are becoming increasingly reliant on irrigation, and and look, there will be opportunities, of course, for Irish agriculture as well. But we need to look at it from both sides. John, we're getting a lot of interest in this topic in the questions I see coming through. Do you want to maybe throw some in?
Yeah, Mark, there's obviously an awful lot of questions coming through. Well done to Conor. It's brilliant to get an insight into the data that's there and try to get a handle on it this morning. Conor, I'll just work my way down through some of these questions. So the first is a comment to the question. So geographers tell us that the thermohaline effect is under severe threat from the quantity of fresh water melt from the Arctic. What is now the immediate effects of climate change in Ireland if this cycle is broken?
Yeah, good question. So I'll talk just very quickly. This thermohaline effect is what's happening in the Atlantic Ocean. So we call that AMOC. It's the Atlantic Meridional Overturning Circulation. We love these long words, these long acronyms. So that's really important for drawing heat up from lower latitudes up to around Ireland. So, if you look across the Atlantic into Newfoundland, it's frozen for most of the winter. That's what gives us our climate, our temperate climate. What we know is that AMOC, that thermohaline circulation, has different phases, basically on-off. It's on at the moment, it has been off in the past, and that results in rapid change in Irish climate, in northwestern Europe, a large-scale cooling and a large-scale drying. What we would expect to see are decreases in annual temperature of maybe 3 or 4 degrees if that was to shut off. And there's work done in the UK looking at the impacts of that on agriculture, and it's not a good look, is all I'll say. It's particularly devastating for future droughts in summer in particular. But we're not clear in terms of what's happening with the AMOC. Some research out there says that it's close to a tipping point. We don't really know. We have long records where that tipping point is uncertain. We need to be thinking about the impacts that we know we're going to be facing and keeping an eye on that. That's a high impact, low likelihood event. It's plausible, but we're not really sure how close we are to it. If it were to happen, it will still take multiple decades for it to turn off, why we call it a rapid shift. That's rapid in climate, long-term scales. The likelihood of it happening this century is still low.
So you mentioned rapid shift there, Conor. We have a lot of questions coming through, so we're going to really have to just move through them there. We have just a question here about your view on nature-based solutions and their place in increasing on-farm resilience. I know it's not necessarily your area of expertise, but maybe you've come across some that have been discussed.
Yeah, very much so. So yeah, nature-based solutions are an important tool in the armory for adapting to climate change. They're unique in terms of they offer win-wins. They offer wins for mitigation and they offer wins for adaptation and building resilience. So I know, for example, great work been done by a neighbour, actually, Tommy Boland in UCD is a neighbour of mine in Wexford, on multiple species swords and thinking about how the kinds of grasses that we're growing, the combinations of different variants, increases resilience to drought, for example. But it also reduces emissions of methane in cattle. We know as well that planting trees, having areas of regrowth or regeneration can be really useful for retaining moisture during drought events. In large parts of the world, they use that as areas of reprieve for droughts, where you have groves of vegetation for biodiversity, for water, for plants, for food, that work during extreme drought events. These are in places of the world that are dealing with droughts all the time. It's really extreme drought events. And again, in terms of slowing the flow for flooding, when you think about agriculture and its relationship with flood risk, how we manage the land is crucial. And we need to see that really important role of Irish agriculture and Irish farmers. But we've a way to go in terms of recognizing, valuing, supporting that role. But that's going to be really important. Slowing the flow, putting in place natural vegetation in order to slow runoff for flooding, retain moisture for drought, and increase water quality. So the short answer is yes, nature-based approaches are valuable.
just another one in here, Conor. You spoke a lot about the intensity of rainfall changing. What does the evidence show related to changes in wind?
Yeah, wind, we don't have those long-term records for wind. And there is, I guess, an uncertainty in terms of what's happening. What happens in terms of future for wind depends on the position of the jet stream. It's another technical, I guess, it's the storm track is what we call the jet stream. And whether that shifts north or whether that shifts south, and even small changes in that jet stream can influence winds over Ireland from storms, but also for solar energy, or for, sorry, not for solar, for wind energy. And looking to the future, there is uncertainty in terms of how that storm track is going to change.
Very good. Is there a specific reason why the east of the country is warming faster than the west or the south?
Some people have given that talk before, asked about, so you have Phoenix Park, Dublin, you know, the Dublin Centre one, is that an urban heat island effect? No, it's not. It's happening in different parts of the island as well. It's related, even the emergence of the climate change signal is likely related to our prevailing weather. So when we're getting westerly winds or cooler effect of the Atlantic Ocean over the west of the island, we see warmer conditions in the east. So it's probably related to that typical or expected climate, and the emergence of the climate change signal can be seen in that. It's strongest in the east, but we see unusual climate in all parts of the island for temperature. It just has emerged as unfamiliar in the east coast. The west will catch up eventually.
Question here about now again more on the emissions side about burning of uplands. Do you think we'd be better off stopping burning of uplands? I suppose it just relates to a very general burning question.
Yes, please. Yeah, I mean, it's how sensitive and important these ecosystems are. Uplands in Ireland often are peatland areas. Peatlands have tipping points as well. You talk about thermohaline circulation. Ecosystems like that have tipping points, and they're really important in terms of water quality. They're really important in terms of water resources in Ireland, the storing moisture, again, building resilience to drought and floods. And when we're burning them, changing the vegetation, it has negative impacts on that. So resilience is about seeing the value of the landscape and how it increases our ability to deal with extreme events. Not to solve them. We're not going to solve these. And this is why I don't like the term solutions when it comes to adaptation. There is no silver bullet here. It's about thinking about all of the things we need to be doing to give ourselves the best chance of doing well, surviving, thriving.
I think you're after answering this one, Conor, but in agriculture, what action will have the greatest impact for climate change? Or is it, as you said there, a number of actions working together?
Yeah, it really is a number of actions working together. And I think what really frustrates me is, I guess, the antagonistic discussions that happen around agriculture. Agriculture is crucial. It's crucial in mitigation and greenhouse gas emissions, but it's also crucial for adaptation. Like I tried to get at the point that what happens in agriculture has so many relationships. What happens in water, what happens with health, what happens in all of the sectors that we're interested in. It's core to Ireland. So we need to be thinking about, you know, how do we pull together the resilience of agriculture, you know, to make sure that it thrives into the future. There's a lot of people's livelihoods invested in this. And you see the impacts from those extreme events.
Yeah, and this probably leads on to the next question. Is there new opportunities for farmers then with the changing of the temperatures and climate change?
Again, I'll caveat it with, I'm not a farmer and I'm not an expert in the area, but yes, you would imagine. I mean, there are lots of opportunities in terms of, you know, thinking about diversification, the emergence of new opportunities that are happening around stewardship. If I call it stewardship, in terms of, you know, land management is going to be a big issue into the future in terms of multiple risks. And it's changing that perception of how important agriculture is for food, for environment, for resilience. It's at the core of all of that. So there has to be new opportunities.
The question, here, I suppose, highlighting maybe there is a gap in some of the teaching that's going on there. I mean, question here is, should meteorology be taught in agriculture programs, and should farmers be investing in irrigation? I suppose two quite separate questions, but that's educational piece. Given that how important weather patterns are, or the impact that they are having on farming, really it is something that needs to be brought up on the agenda in terms of
Very much. Yeah, very much so, and that's recognized. I think, all agricultural science university programs should have this component. I'm not sure if they do yet or not. I'm probably thinking not so much, needs to do more. But we're starting to see that shift. I mean, we have at secondary school level now this new compulsory module coming in terms of climate and sustainability, and really understanding at a local scale what is at risk, what's happening, what's at risk, what can we do, how can we be more resilient. Getting that onto the agenda of, everybody's education is important. We all need to know about this, and how important agriculture and water, it's the core of who we are as an island.
Mm-hmm. And the irrigation piece, I think it's happening already in some parts of the country. I know down Wexford, potatoes are being irrigated for the last number of years.
Yeah, horticulture in the east of Ireland uses a lot of irrigation in particular. Again, that'll come down to individual farm level actions. I'd encourage individual farmers to be thinking about what can be done. A lot of every farm is different. There's the soil texture, whether it's exposure to prevailing weather conditions. Every farm is unique, and thinking about the kinds of services that might be needed from Teagasc's perspective in terms of helping individual farmers to build resilience. The general theme of actions might be the same, but they'll be unique and different at individual farm level. Some might need irrigation, others might not for the same individual crop.
Okay, we're coming up to close towards the end of our session today. John, we have time for maybe one or two more.
Yeah. Comment on a question, should our first priority be to produce our own food needs to build resilience against supply shocks, shortages from elsewhere?
Sorry, go ahead. Do you want to give? I'll deal with them together.
Move on to Has the impact of changes to the Gulf Stream on our climate been factored into your calculations presented today?
Deal with those two then. So food, concentrate. Yeah, we are the most open economy on the planet, if not the most up there, reliant on external trade, imports and exports, really important to our economy. We need to be focusing on food security, of course, but we also need to have that important interaction with our global markets. I do think we need to place more emphasis on local food. That's a consumer challenge as well for Irish agriculture. We need to be supporting Irish agriculture in that regard. And again, that value of sustainability around food consumption and producing locally, purchasing locally, really important to food security. And I think I've answered the issue around Gulf Stream. The observations, what I've been showing you is predominantly on observations. The model projections that I showed you around drought include climate models, but they don't explicitly look at anything around the breakdown of the Gulf Stream or AMOC. They're the same process.
Okay, Conor, we're going to have to leave it there. We're right out of time. I don't know where that hour went. You really covered so much in that short space of time, and it's a topic that I think needs more airing, needs to be brought to the fore, particularly in terms of I suppose the actions that are happening and the policy measures that have been introduced at a national level to support farmers in this change. Look, we really value the work that you're doing in your team in Maynooth, and I know you're collaborating with lots across Ireland, but it's important work that we know how to build that resilience across agriculture in Ireland, and also understand the impacts that are having in other countries as well. That likely future for agriculture here in Ireland.
It's a pleasure. Thank you for having me. And if I could just leave with the reminding people of the ICA report, the Irish Climate Change Assessment Report. It's on the EPA website. If you just search ICA, ICCA, Volume 3 looks at agriculture. There's a chapter in there, and it really points to what we need to do to build that resilient Ireland. Agriculture is part of that. So to start that conversation.
Thanks, Conor. Yeah, no, it's an excellent report. It's very, very easily accessed there on the EPA website. John, thanks very much for helping with questions this morning. And if we didn't get through all of them, there's a huge interest in this topic, so no doubt we'll be covering it again sometime soon in the future. Next week, we're going to be joined by Mary Frances Rochford, who's Programme Manager from the climate change section in the EPA. So Mary's going to be talking about the opportunities of climate action, and no doubt we'll be referring to that very report that we discussed there today. So I want to say thank you to Mary in the background for helping with the technology today. And we hope you have a good weekend and look forward to seeing you next Friday again. So until then, thanks for joining us.
Thank you.